Okay, so hello everyone. In this video, we will be solving the question number 3720, which is lexicographically smallest permutation greater than target. The question is marked medium. Question is very easy to understand, and we will also solve it step by step, every building brick by brick, so that you can understand the approach as well. So we'll first understand the question, move to the understanding part, move to the examples, and then we'll build the code. Okay, so let's start with understanding the question. So what does the question wants to say is that we are given two strings s and target, both having same length, both having length n, okay, which consists of lowercase English letters. Okay, now what we are supposed to do is we need to return the lexicographically smallest permutation of S, which is strictly greater than the target. So we are given two strings, which is S and target. Both have same size, which is n length, and we need to return the lexicographically smallest permutation of S, which is strictly greater than target. So let's first understand these terms, what does it wants to say, and then move. What does lexicographically smallest means? So what does lexicographically means is that whenever we think of a lexicographically, it means alphabetical manner, and lexicographical, what you can say, comparison is done on the basis of order of appearance. As we know that B appears after A. B appears after A, so B is considered greater than A. Suppose let's take another example, BCD and ACD. We start the comparison from left to right. We check this B and this A. We get that okay, this B is greater than this A, so this entire string is greater than this string. Let's move to this example. Here we can see that when we try to compare first two, when we try to compare these first two elements with these first two, we see that both are same. So we move to the third element, which is this B. This B is compared with this A, and we find that okay, the B is greater than A. So this string is greater than this string. And but what if they don't have the same length? So we can say that we compare the first one A with this A. We find that okay, this A, first A is same. Which one? This, sorry, this A is same. And when we try to compare this last A, we find that there is nothing to compare, so this is greater. But you can say that B is greater than AA. Why? Because when we compare this B with this first appearance of A, we find that B is greater. And now what is the permutation? What is permutation? Permutation is nothing but rearrangement of its length, of its elements, and its length is preserved. Suppose we take ABC, we can say that ABC can be, the elements can be rearranged from this many permutations: ABC, ACB, BAC, BCA. These all are the permutations which are formed by rearranging the elements, rearranging its elements. Now what we have to do is we need to return lexicographically smallest permutation. Like these all are the permutations, and from which we need to find the lexicographically smallest. We can say that ABC is smaller than ACB. Why? Because of the second element here. This B is smaller than this C. Okay, which is strictly greater than the target. So let's first understand. Here we are given S is ABC. Here let's understand. We are given that ABC is given as S and target is BCA. So we need to find the smallest lexicographically permutation of S which is greater than it. Here are the combination permutations, and we need to find the permutation which is just greater than BCA. We can see that there are two permutations greater than BCA, which are CAB and CBA. So we choose CAB as the answer. Okay. And if there is no permutation which is lexicographically strictly greater than target, we return empty string. Suppose here target was CBA we see that there is no permutation which is greater than CBA. So we return an empty string in that case. Okay. So how we will do is suppose we are given a target suppose ABCD. Okay, and we need to find the lexicographically smallest permutation of S. So how we will do is, what we will try to do is, we will try to form or build from left to right. Here, since the number of permutations were small, we could have checked all the permutations and find that okay, there is no possible answer for CBA. If target was BAC, we could have find BCA. But what if the size is so big? Because finding permutations takes n factorial time complexity. So how we will do is, so suppose let's take the same example, S equals to ABC and target equals to BCA. So what should be a target is start building from middle, like not from middle but from anywhere, because if we try to start building from the basic or the first, what you can say, permutation, it will take so much time. So we will start building from the requirement, or you can say what is the requirement here is the target. As you can see that our target is BCA, so why don't we try to build from BCA only? Are you getting it? Suppose I have S as ABC. ABC or ACB, it doesn't matter because we need to find its permutations only, right? Suppose S is ABC and this is our target. Okay. So what I will try do is I will try to start building. How I will try to start building is, suppose I try to make target first and then make just greater. Is that possible? Let's check. Suppose also it may be possible that target may not be permutation of S. Okay. Suppose target be BCD. Okay. Okay. So what we will do is we will try to start building from leftmost side. If we try to put an A over here, we can say that it will definitely be not greater than target, as the during the first checking phase only, target will be greater. And what we need is, we need our answer to be strictly greater than the target. So we know that okay, if we want to start building, it should be equal to or greater than our then desired target element. In this case, what we are doing is we are targeting B. So our answer should be starting from either B or C or D or E or whatever it is. Suppose I put an B over here. We can say that we have exhausted one B and now I have only two options left, which is A and C, because our answer should be a permutation of S. So it can only consist of the elements which are part of S. Now we know that okay, B is taken, so now only A and C are available. So if I try to put an A over here, this A will be compared with this C. So we will be like, okay, putting an A here won't work because build will be, what you can say, marked smaller when it is compared with this C. So we cancel A and try to put C over here. Now we will be like, okay, this is still into consideration when we try to compare with this. So now we have exhausted C also. Now we have only A available. So if we try to put an A over here, this will be compared with this D. And we will be like, okay, now what we have done is all the elements are exhausted. and a build is also smaller. So I need to restart. From where I'll try to change this element, which is the A. But we know that we have no other option. So what we will move one more step back. But if we know that we check all the both the possibilities of putting A over here or a C over here, that won't work as well. So I'll try here first element. We know that putting A won't work. We check B also. B will not work. Now I will try C. So I have two options now, which is A and B. So if you know that when I put a C over here, it is automatically marked greater. So putting an A over here or B over here won't make any change, because a C, when I put a C over here, this build was automatically marked greater. You can say that here also this B is greater than both A's. So if I put an AB, this is also greater. CBA is also working. What we want is just greater. Lexicography is smallest, which is greater, strictly greater than target. So CAB and CBR are greater, but among them which is smaller? CAB. So our answer is CAB. So what we will do is we will build from left to right, and we will check why. What we will check, suppose if I put an C over here, suppose if I put an C over here which is greater than this, we can now in future we can think like, okay, now I put any number, any element, it will work. Why work? Because our build is now greater than the target. Suppose let's take one more example. Okay, suppose our S was ABCC and the target was our target was CBCD. Okay, now what I'll try to do is I'll try starting building from left. Okay, A won't work because it will be compared with this, so cancelled. B also will won't work because it will be compared with this, so build will mark smaller. Okay, now I try C. It will be taken into consideration that now what appears after this, this will be checked with what we write over here. Okay, so if I put A over here, it will be rejected over here. If I put B, then C, then A, this A will reject my build. This A will reject my build. So if I try changing over here, we have no other option, so we'll try changing over here. Here A won't work because it will be checked with this. So I have only one option. This is to change this B to C. Now we know that this C, when it was checked with this B, this was automatically marked bigger. Build was marked bigger. So either I put A B or B A. Both the answers are correct, but I'll prefer A B. Okay. So what I'll try to do is move from left to right and check, is my build greater than target? What is build? Build is not complete string, but whatever I have built till now, is greater than or not. This C is not greater than this C, but this C is greater than this B. So if that happened, the relative order of the suffix did not matter. But here, when this C was equal to this C, the relative order of the suffix did matter. So is my build greater than? If it is true, we can put any elements, but we want smallest, so we will put elements in the increasing order or ascending order. Okay, if that's not the case, If that's not the case, you might made one observation is that our build is considered what you can say greater or valid if we start from the element which is equal to this or it is greater than this. Suppose our s was a and our target was bcd. If answer target was bcd, so we started from c because it was required. So if it is false, we have two possibilities, which what you can say we will start from the required element. In this case, the required element was b, so we will start from b only. A will not work because we know that a was automatically rejected. And then we will check if our build equals to the required size, which is required size is nothing but target size. And since integer build is a permutation of s and target size as length size as equal, so build equals to s dot size, or we can say that we can consider target size also. And then we will check if build is greater than target and smaller among formed. Okay, if that's the case, we'll update the answer. So let's just move to the implementation part and then we will optimize it. We are solving with two approaches. This is the first one and then we will optimize this current one. Okay. So let's move to the implementation. Okay. So yep. So what we will do is we will when we were building this build, when we were building this build, after we chose this C, we were like, okay, now we are left with two options, which is AB and AB. So we were also keeping the track of their frequency. Suppose our S was ABCC and the target was CBCD. So when we put the first C, we were with, okay, now I have these three options. Or one of the C is exhausted and ABC is still left. So I'll build with this much. And now when I try to put B, I was like, okay, now I have only two options, which are A and C. But later I realized this B won't work. So I need to put a C. So what I will do is now I'll replenish my, what you can say, the frequency of B. Now it will become AB. And when I put C, I'll used or decremented the frequency. So while we are building, we will decrement if we use the element, or and we will increment when we want to replenish the element. Okay, element's frequency. So first what we want is we want a frequency array, and since we know that it consists of only lowercase letters, so its maximum size will be 26 and by default we will give them 0 frequency. Now we will iterate over the s and update the frequency. How we will do is frequency of val minus a. So val is a character, and when we subtract a character from a character, we get a number. And by doing this, we get the how far a particular character is from a. If this value is a minus a will become 0. So we can say that at 0 index, it will be mapped with a character a. Okay. Now we have done this to get the frequency of elements of S. Okay. Now after we have found the frequency, now what we will do is we will try to build it. And we know that build was an trial and error. Not trial and error you can say, but we put and check. Okay. So since this is a try and put and check, we can think that this is a recursion, but we don't know what we will be returning. So as of now, I'll just be right, okay, let it be a helper function in which I'll use like it is but obvious we want one index element index I, and we will use string target because we want to make according to it, and string build, as we are making that new string. We will also need frequency because when we use a particular element, we want to decrement its frequency and know which particular elements are still present. As of now, I think I need this much. No, I need one more thing, which is bool, which is to mark that is the build greater than the target. Okay, what is the bool? Uh, is a present bool greater or not? Okay, if let it be if I reaches target dot size, what we need to do? We will do that later on. Okay, let it be base case. Now what we will do is for we will try putting each element for int I equals to 0, I less than 26, I plus plus. Okay, now we will check if present element or present build is greater or not. We can say our build is greater or not. Why? Because when I put this second C over here, I was like, okay, now I can put anything over here. So just to get that, what I need to put in the suffix I want is greater. Because when I put this C over here, it was just equal. The relative order of the suffix was to be matched over here to know. Okay. So if we know that it is present is greater, we can put anything. Can put anything. So first we will check if its frequency. We will use j over here. We will use so that I and j are differentiated. If the frequency of this element is greater than 0, so then only it can be used, right? So it can be used. If it can be used, what we'll do is we'll append it to j a plus we will append it to build. If that's the case, and then we will call the helper function to next element I plus 1 target build frequency present greater. If that's not the case, we will continue. Next element will be check here. Or what you can say is now after finding this we can break, because now we are going in from increasing manner. So our answer will be now whatever will be formed, it will be in increasing manner. So we do not need to check what follows, because this current element will not be replaced. So we will break over here, because if here if I after cc if I put a, I do not want to check after putting b, because it will form ba, and I know that ab will be the more appropriate, more apt than putting ba. So after putting a, I will like, okay, don't check of putting b over here. So that's why I have put a break over here. If it is not present is not bigger, build is not bigger. So what I want to do is first I will check if a plus j is greater than or equals to, or we can be like, okay, if a plus j is less than target of I. If that's the case, I will continue. because here putting a B here won't work. Why? Because this C, when it will be compared with this B, we will be like, okay, our build will go in, will be smaller only. So we will not waste time making a permutation. So we will continue. Now we got that, okay. Here we can say that chosen alpha is smaller than comparing element. Okay. If that's not the case, it means that chosen alpha is greater than equal to comparing element. But what will we choose if its frequency is not available only? If frequency of j is less than equals to 0, it is of no use, right? So we will continue. Okay. Here it means that it is of no use because it cannot be used only. Its frequency is, exhausted. Now, if it reaches this line, it means that its frequency is there. So what we will do is, so we will append it to build a plus j. Now I have appended that character to what you can say build, and I will reduce its frequency by 1 because we have used it, right? And I will check if a plus j is greater than, if a plus j is greater than target of I, if that happens, it means that our build is now greater than target. Okay. Or we can say that when I put another C over here, I was like, okay, now my build has overtaken the target. If that's the case, what we'll do is we'll mark present greater as true. Okay. Yes, we will mark the present greater as true. We'll call the helper function, which will be I plus 1, and target build frequency and present greater. Okay. If after that happens, I'll be like, okay, now when it returns back, I want to remove those changes, and like, so that another possibilities can be checked. Just a second, guys. Okay, so after it has like come back over here, now we will try to put another one. So what now, after that we'll mark present greater to false. Okay. Yes. And here if it gets into else loop, it means that a plus j equals to target of I, because the smaller ones were eliminated over here, the greater ones were checked over here, so here the equal ones are done. So we will call helper, so our present greater will remain as it is. So I call helper I plus 1 target build frequency and present greater. Okay. After all this, we need to replenish the frequency. So I'll frequency of j plus plus. Yes. Here also, I guess we need to replenish. Yeah. Okay. Here we did not decrement only. Frequency of j minus minus. Frequency of j plus plus. This is to replenish frequency. Here we will also replenish frequency. And like what we added over here, we need to pop back as well. So build dot pop back. Likewise here as well, I need to pop back. Okay. If our build is greater than this, if else, that's the case. Now suppose we reached over here, that I has reached the end state. First we will check if build is greater than target or not. If that's the case, our answer, we will declare the answer, and we will check here as well if build is greater less than answer or not. If that's the case, answer is equal to build. So our answer should be greater than target, and among those possibilities it should be the smallest. And here I'll simply write return. After this I'll write return. Okay, I'll create a okay, let's make this answer global. String answer equals to okay, and bool updated equals to false. So I'll check if our answer is updated or not. Updated equals to true, means we have one possibilities. And what I'll try to do is I'll make answer the biggest possible. Answer plus equals to z. And so if suppose the length s is abc, so our answer initially would be z z z z. So whenever a possible combination permutation is formed which is greater than target, when it is compared with answer, whenever it is compared with answer, it will be smaller than this, because if it is z z or z, it will be smaller by length. Okay, and now we will call this function helper 0 target build frequency, and this is for string build equals to, we'll check if updated equals to false, it means that there is no possible answer, we will return empty string, otherwise we will return answer. Okay, I guess this should be correct. Whatever it is, we will then solve it. Okay, void, this is void, it doesn't return anything. Okay, I guess this should work, because okay, main agenda is clear, so we will correct on the way. Okay, we know that after there will be two cases, here and here. Just a second, I'll add one counter. You can think that when we are putting these elements, like which is greater than or equals to what you can say the element here, here, here. If I put B and check, okay, and when I put B and check, we know that either in B or either in C I'll get the answer, because if it's a B, there is a possibility that this suffix may be smaller than this one, but when I put a C it is definite, so I do not need to put an D over here to check, or any element which is, you can think that part of S. So here we can only need two possibilities, either B or C. Here also I only needed two possibilities. Suppose our target was BCCD, okay, let it be BCCA. So suppose I put a B over here, there would be a one chance. When I put a C over here, there was a definite chance. Okay, so I just need to put two numbers, either B or C or whatever it was. I just need two numbers. So after putting two numbers, I'll be like, okay, I am satisfied. So I'll increment counter plus plus over here and increment. So whenever I count, I'll be like, okay, I have got my answer. I will break. Okay, what is the issue? Okay, it's it. Okay, as you have seen that this is accepted. Why? Because after two checks over here, okay, I'll be like, I have definitely gotten my answer.